Good afternoon to all of you. In this lecture, we are going to discuss image compression with graphics interchange format, that is GIF. The graphics interchange format was developed by Comprehensive Information Service to encode graphical images. It is another compression implementation of LZW techniques and is very similar to compress command. Compress command. It is another implementation of LZ algorithm. The compressed image is stored with the first byte being the minimum number of bits b per pixel in the original image. For the images we have been used, this would be 8. The binary number 2 to the power b is defined to be the clear code. This code is used to reset all compression and decompression parameters to a startup state. The initial size of the dictionary is 2 to the power b plus 1. When this fills up, the dictionary size is doubled as was done in the compress algorithm until the maximum dictionary size of 4096 is reached. At this point, the compression algorithm behaves like a static dictionary algorithm. The code words from the LZW algorithm are stored in blocks of characters. The characters are 8 bits long and the maximum block size is 255. Each block is preceded by a header that contains the block size. The block is terminated by a block terminator consisting of 8 zeros. The end of the compressed image is denoted by an end of information code with a value of 2 to the power b plus 1. This code word should appear before the block terminator. On most images, PNG can achieve greater compression than GIF. PNG gives a much wider range of transparency options than GIF, including alpha channel transparency, whereas GIF is limited to 8-bit indexed color. PNG gives a much wider range of color depths, including 24 bits and 48 bits true color, allowing for greater color precision, smoother fades, etc. When the alpha channel is added, up to 64 bits per pixel are possible. GIF intrinsically supports animated images. PNG supports animation only via an official extension. See the sections on animation above. PNG images are widely supported, for instance, with modern web browsers and office software, but not as widely supported as GIF images. What is JPEG? Unlike GIF graphics, JPEG images are full color images, that is 24 bits or true color. The JPEG come into two flavors, a standard JPEG and a progressive JPEG. First, a blurred image is displayed, then as more information flows in, the clarity increases. Progressive JPEG images often take longer to load onto the page than standard JPEGs, but they do offer the reader a quicker preview. These are some examples of PNG format and GIF format, and this is JPEG format, example of JPEG format. As you can see, this is the most clearer image. Now the advantages: it is fast to compute compared to many other suitable image transformations. It usually tends to result in low values for the weights of some of its basic images. The image that results from deleting low weight components is generally pleasing to the eye. Now we will discuss another topic, that is compression over modems version point v.42 bits. The ITU-T recommendation v.42 bits is a compression standard devised for use over a telephone network, along with error correcting procedures described in CCITT recommendations v.42. This algorithm is used in modems connecting computers to remote users. The algorithm described in this recommendation operates in two modes, a transparent mode and a compressed mode. In a transparent mode, the data are transmitted in uncompressed form, while in the compressed mode of an LZW algorithm is used to provide compression. The reason for the existing of two nodes is that at times the data being transmitted do not have repeated structure and therefore cannot be compressed using the LZW algorithm. In this case, the use of a compression algorithm may even result in expansion. In these situations, it is better to send the data in an uncompressed form. A random data stream would cause the dictionary to grow without any long patterns as elements of the dictionary. This means that most of the time the transmitted code word would represent a single letter from the source alphabet. As the dictionary size is much larger than the source alphabet size, the number of bits required to represent an element in the dictionary is much more than the number of bits required to represent a source letter. Therefore, if we try to compress a sequence that does not contain repeating patterns, we would end up with more bits to transmit than if we had not performed any compression. Data without repetitive structure are often encountered when a previously compressed file is transferred over the telephone lines. The V.42 bits recommendation suggests periodic testing of the output of the compression algorithm to see if data expansion is taking place. The exact nature of the test is not specified in the recommendation. In the compressed mode, the system uses LZW compression with a variable size dictionary. The initial dictionary size is negotiated at the time a link is established between the transmitter and the receiver. The V.42 BIS recommendation suggests a value of 2048 for the dictionary size. It specifies that the minimum size of the dictionary is to be 512. Suppose the initial negotiations result in a dictionary size of 512. This means that our code words that are indices into the dictionary will be 9 bits long. Actually, the entire 512 indices do not correspond to input strings. These 3 entries in the dictionary are reserved for control code words. These code words in the compressed mode are shown in table. When the number of entries in the dictionary exceeds a prearranged threshold C3, the encoder sends the step up control code and the code word size is incremented by 1 bit. At the same time, the threshold C3 is also doubled. When all available dictionary entries are filled, the algorithm initiates a reuse procedure. The location of the first string entry in the dictionary is maintained in the variable N5. Starting from N5, a counter C1 is incremented until it finds a dictionary entry that is not a prefix to any other dictionary entry. The fact that this entry is not a prefix to another dictionary entry in this way, the dictionary is always matched to the current source statistics. To reduce the effort of errors, the CCITT recommends setting a maximum string length. The maximum length is negotiated at link setting. The CCITT recommends a range of 6 to 250 with a default value of 6. The V.42 BIS recommendation avoids the need for an exception handler for the case where the decoder receives code word corresponding to an incomplete entry by forwarding the use of the last entry in the dictionary. Instead of transmitting the code word corresponding to the last entry, the recommendation requires the sending of the code words corresponding to the constituents of the last entry. Now,